Okay, in today's lesson, we will be covering the Bohr model and the Lewis dot structure. So, in this case, to do this, we're going to need our periodic table to look up the number of electrons. Okay, so make sure you have out your periodic table. So, the first example that we're going to do is beryllium. So, this is an isotope of beryllium, beryllium 9, 9 meaning the mass number. So, we're going to take a look here and find beryllium. It is number 4 here, symbol Be, beryllium. And the mass number is also 9. Remember, these are just averages. Okay, so sometimes on this worksheet, the mass number you're given may be slightly different than the one on the periodic table. So, the atomic number tells us that there are 4 protons. So, we're going to fill this in here for beryllium. For protons, there are 4. Now, for the number of neutrons, well, how do we figure that out? So we have to go back, look at our periodic table, and the number of neutrons is equal to the mass number minus the proton number. So we're going to take 9 minus 4, and that gives us 5. So this total, 4 plus 5, should equal 9. That's how we get the mass number. Now, as for the number of electrons, there's only 4 electrons. So we have to place those in our orbitals. Now, I just want to go back and help you remember. We can make this note on the top of our worksheet. In the first energy level, it can only hold up to 2 electrons. The second energy level can hold up to 8 electrons, and the third energy level can hold up to 18 electrons. Now, those are the most they can hold in each. Now, since we have to place 4 electrons, so the number of electrons are equal to the number of protons. So this will be our very first orbital or energy level. We're going to place 2 electrons. 1, 2. Now we need a total of 4. So the first level can only hold 2. So now we move to up to the second level and place 2 more. So we're going to go 1 and 2. So now we have our total of 4 electrons. Now, the Lewis dot structure of beryllium, here it's a little simpler version. The Lewis dot structure consists of the symbol and just the 2 electrons in the outermost energy level. The number of electrons in the outermost energy level. In this case, beryllium only has 2 electrons in the outer level. So we're going to place them around the symbol, like so. So we'll put 1 electron here on top and the second electron on the side. So we kind of imagine there's like an invisible box around the symbol, and we start placing the electrons. Okay, so that's one example. Let's move on to this number 2, sodium. So it says sodium 23. So sodium here is symbol Na. The atomic number is 11. And again, the mass number is 23. So in this case, the mass number on the worksheet does match the one on the periodic table. More importantly, so let's focus on the atomic number, 11. That means there's 11 protons and 11 electrons. So for protons, we're going to write in the number 11. Now, as for how we figure out the number of neutrons, again, we're going to take to find neutrons, our mass number minus protons. So we're going to do 23 minus 11, and that will give us 12. So it has 12 neutrons. Now, to place the electrons. So there's a total of 11 electrons. So the first level only gets 2 electrons. So 1, 2. We need a total of 11. So the second level can only hold at the most 8 electrons. So we'll place 8 electrons there. So it's 1, 2, 3, 4, 5, 6, 7, and 8. And we place them like that because electrons have a negative charge, and they basically repel each other. They push away. So we kind of space them out evenly. So this gives us a total of 10. So 2 in the first level and 8 in the second level, 10. We need 11. So that single electron moves up to the third level. So it goes right there. Now, we call that electron the outermost energy level, the valence electron. And that's the electron that gets placed in the Lewis dot picture. So it's a simpler version of the Bohr model. So you have the symbol Na, and literally with just one dot, meaning one electron above it. So that's how we represent the Lewis dot structure of sodium. So in this case, we'll do one more example. We'll do number 4, fluorine. Okay. Fluorine on your periodic table is letter F, number 9. That means it has 9 protons, 9 electrons, and a mass of 19, which happens to be the same number here. Okay, so number of protons for fluorine is 9. Now to get the neutron number, we take the mass, which is 19, minus the proton number, so then there's 10 neutrons. So now we have to place 9 electrons. So first level can only hold up to 2 electrons. So we'll go 1, 2. Now the second level can hold up to 8. However, we only need 7 to get a total of 9. So we're going to go 1, here's the second one, 1, 2, 3, 4, 5, 6, 7. So that gives us a total of 9 electrons total. 2 in the first level, 7 in the second level. Now for the Lewis dot picture. Alright, I'm going to zoom in a little bit. So we have the symbol F. We're placing the valence electrons around the symbol, which means there's a total of 7. So here's how we do it. Remember, we're imagining there's an invisible box around the symbol. So we're going to place it in this order. I'm going to go 1 on top, 2 on the side, 1 on the bottom, another 1 on the left side. So that gives us a total of 4. Now we need 7. So the fifth one goes on top, 6th on the right side, and the 7th one on the bottom. So the Lewis dot picture of fluorine looks like this. So it's a simpler version of this. And the reason why we only include the outermost electrons is because it's those electrons, those valence electrons, that are very important when it comes to chemical bonding, which we'll get into in upcoming units. So now the rest of this is going to be yours to work on. So you have the front side of this worksheet and also the back side to finish as well.